There are vocals in this music, and I don't like that. Sneaky steps and shadowy ways. Welcome to the lair where the code is crafty and the hacks are always ethical. Let's dive into the shadows. Alrighty guys, so I'm back with, turn the music down just a smidge. So I'm continuing on with my, Game of Active Directory series. I found out something very interesting. So I have started using the community edition of Bloodhound instead of the regular, like, desktop version of Bloodhound. And one thing that I was not really understanding is there was an attack path going from cal.drogo to Bravos, and what the desktop app didn't show is, so a little bit more on that story. I was able to compromise Bravos as cal.drogo, which didn't really make any sense to me because I thought that I needed to carry out the attack chain first. But in Community Edition, as you can see here, cal.drogo is actually an admin to Bravos, so that makes a lot more sense there. Alright, so let's see what I'm gonna do today. So what I was working on is, let's see. But yeah, so, I used Certify to find out what, certificates were, or not certificates, certificate templates, are vulnerable to the different escalation types. And we were just starting with one, which is right down here, escalation 1. So the template name for this is just ESC1, just kind of for, ease of use and usability in a lab. So they basically just called the template escalation 1. So we were trying to tackle that and see if we could maybe compromise the root domain controller, which lives at 172.16.0.10, because we've already compromised all the other machines besides King's Landing. So we've compromised Castle Black, compromised Bravos, compromised Winterfell and Meereen. Winterfell was actually the first machine that we were able to compromise because we set up a LLM&R poisoning attack and were able to capture the NTL MV2 hash for the rob.stark user. We then were able to crack that hash and recover the password for that user. And then we found out that they were actually an admin for this machine. And actually, I believe they are a domain admin for the north.7kingdoms.local domain, because I was able to dump the ntds.dit, which contained all of the password hashes for every single user in that particular domain. So continuing on from last time, so I think I'm just living in the enumeration tab right now. Even though this is more like post-compromise. But I didn't create a tab for that. But anyway, so we're looking at abusing ESC1, or escalation 1. So what I started out doing is, so let's see. So this right here is just an example of the syntax for the command, I believe. Yeah. So I was using certify. There was an issue with this command. I think there is still an issue. Where did I figure this out? Oh yeah. So what it ended up working is use certify request, specify the username of cal.drogo at essos.local, this identity, and then I set the password as horse, which you found out was cal.drogo's password a while ago, and set the target IP to .23, which is Bravos. Because they are, like we saw earlier, an admin over Bravos. And then, let's see. And then we set the certificate authority to essos-ca, which, if I scroll back up, can see that that is the certificate authority for all of these templates. So like you have escalation 1 here, essos-ca. Okay. Go back down here. Oh yeah, so let's see. So first I attempted to do this with a UPN, user principal name of administrator essos.local, this identity here. And as I mentioned before, using the ESC1 or escalation 1 template. So we were able to get a certificate and a private key for to administrator.pfx. So we have this certificate and private key in this form. And then I also tried to do this for the user principal name of administrator at sevenkingdoms.local, just to see if I could use these credentials and this template to get a certificate and private key for this UPN, because this is the sevenkingdoms.local is the root domain. So trying to see if maybe I could escalate to domain admin using that. And then so we have that administrator.pfx, and then I was trying to authenticate with this pfx file, but ran into an issue with that. So I was not able to get a ticket granting ticket, and got the error KDC error client not trusted. And then I tried to output this to output the pfx file, or extract, I guess you could say, the certificate from the administrator.pfx file, as well as the private key. And then I was trying to use a Python tool called pass the cert. I kept getting invalid server address with that, and then I looked at the help menu. Let's see. User not found in LDAP administrator, which is interesting. Yeah, SAM account name administrator not found in DC equals 7 kingdoms, DC equals local. And then I tried admin, and that also didn't work. This said to specify the fully qualified domain name. And then I tried this one more time. This didn't give me any output this time for some reason. Oh, wait, actually I think I probably canceled this before I ran this with Control C. Then I tried to see what credentials I had to see if anyone actually has access to sevenkingdoms.local. Okay. And that's where I stopped. Yeah, okay. So I don't have as much time to do this anymore. To like spend time trying to like figure out stuff on stream anymore because I have a full-time job doing junior detection engineering now. So I think what I'm going to do is I'm just going to follow the guide for Game of Active Directory. And we're just gonna go ahead and use the guide so that I can kind of demonstrate how this attack actually works without having to like actually go through and like tinker around and try to figure it out, because I unfortunately don't really have time to do that anymore on stream. So yeah, that's how we're gonna play this now. Oh. Thank you for the follow, King Potato. Ooh, I think all of my audio and stuff got messed up, unfortunately. I don't know if maybe you guys can hear the alerts and stuff. I didn't really have time to test that today, but if that isn't working, I'll be sure to get that working again. Let's see. All right, so I'm just going to, let's see. I think I'll just work in the initial access tab. I could even make a new tab called post-compromise. Post-compromise. Yeah, we'll just do that. Okay. Make this quite a bit bigger. Okay, so I'm going to go ahead and remove everything that starts with administrator. I think that should be fine. Yeah, okay. And we're just gonna start over again. So certify-ad, and then the rest of this. Okay, so we're gonna use find. Actually, we don't really need to use find again, because that's just showing us. Oh, this is interesting. Wait, can we actually see this in Bloodhound? Let's see. Cypher. Can we see? Let's see, what is... Let me drag this over here. Find misconfigured certificate templates ESC1. How do we actually run that in Bloodhound, I wonder? Unless maybe we somehow didn't collect that info. Hmm. Find misconfigured certificate templates. Okay, so they did that with Certify like I did, but I think it would be really interesting. Oh, that's right. We have a zip file that Certify creates that we can import into Bloodhound to see that. I forgot about that. So let's do that. That'd be really interesting to see, I think. Okay. So we'll go to administration and we'll go to file ingest. We'll upload file and I think this is what we want. Or no, let's see. Documents, code. I think it might be... Oh, I forget what that looks like. Just a second. Oh yeah, I have to unzip. Let's see. And my VM froze again. I still haven't been able to figure out why that's happening. There it goes. Okay, so let's see if we can find this. So earlier in initial access, no wait, not initial access, enumeration. There was a file that was output when we ran Certify to find out what templates existed. Saved Bloodhound data to... Oh, okay, so it's this certify.zip file. Drag and drop the file into the Bloodhound GUI. Okay, that's all we need to do. We're working in the post-compromise tab. Okay, so we'll go here, and this is in this, and then this right here. Open, upload, upload. There we go. Okay, so that should be imported now. If we go back over to Explore, and we go to Cipher, let's see, I think that should give us a searchable query now for certificate templates. Oh yeah, here we go. Awesome. Okay, enrollment rights on published ESC1 certificate templates. So we can run that. Wait, no results match your criteria. What? Oh, what if I run this instead? No? Oh, man. Oh, we have an ad break going on right now anyway. This isn't finding anything for some reason. Do I have to, like, have something selected? Do I have to have a node selected? I don't think so. I wonder why that isn't working. Let me see something. Did I pick one that did not work correctly? Let's see. Oh, no, that did work. Yeah, okay, so here's this text document. We have certify.json. But this one is specifically for Bloodhound, and that was the one that I just imported, so I'm not sure why we're not seeing any data. I wonder if we need to like refresh the database or something. Oh, wait. All files failed to ingest as JSON content. Oh, no wonder. Yeah, because this is today. Crap. Okay, I wonder if this needs to be... I wonder if this needs to be extracted first. Unzip. Yep. Wow, that's exactly the one that I wanted. Okay, alright, so... Now we have these JSON files. Yeah, I think this had to be extracted. Now, if we try to re-import this, I think this should work. Cast templates. $38 seconds, 36 seconds. The top of my mic gets dusty when it just sits around, so I was just dusting it off. Okay. About 10 seconds. Alrighty, and we're back. Okay, so the reason, I don't know if anyone saw because of the ad that, interrupted, but, so I was looking at Cypher, and then we have, well, actually, so, let me go back. So earlier, I tried to import the Bloodhound data for certificate templates, but I didn't realize that the status failed. All files failed to ingest as JSON content. So I extracted the zip file, and now I got two files that we're gonna import and see if we can see the vulnerable certificate templates. Wait, what? Why is there another ad? What is going on? is there another ad playing? Oh, maybe there isn't another ad playing. Alright, anyway. So I'm going to import both of these JSON files now, and we should be able to see the vulnerable certificate templates. What? No error saving ingest file. No valid meta tag found. Oh, wait a second. No? It should work. Right? Oops, wrong tab. Alright. Okay. So that didn't work for some reason. But this should be... This should contain the Bloodhound data, for the, vulnerable templates. What did I do? Let me get back to... Yeah, so this is for the certificate templates. So it saved the Bloodhound data to this file. It just says drag and drop the file into the Bloodhound GUI from... Oh, wait a second. I wonder if this doesn't work for Bloodhound Community Edition. Because it uses a different ingester. Because this says the Bloodhound GUI. I mean, I guess the Bloodhound GUI could be the GUI for Bloodhound Community Edition too, but I'm not really sure about that. This didn't seem to work. Let me see. Yeah, so this failed. Wait a second. Did this actually work? It says that it's complete. So maybe that did work, even though it threw an error. Let's take a look. So we'll go to Explore. We'll look at these. We'll scroll down a little bit. Kerberos. Enrollment rights on published ESC1 certificate templates. No, there's still no data. There should be data for that. Oh well. Alright, so continuing on. I guess I'm not gonna be able to show this in Bloodhound. Okay. I mean, oh, well, so, I guess there are screenshots here so that we can see it here. Import the zip file created with Certify. I'm sure this is probably the, desktop version of Bloodhound. Probably not the community edition. Hey, good evening, Cypher. Good to see you. Thanks for joining. Let's see. Okay. So anyway, looking at this, we can see this right here is the certificate authority. And we have all of these templates. There are tons, actually. There's more than even just the escalations, but we have escalation 1, escalation 3, escalation 4 here. I think this is 8, maybe? No, wait, no, that's not one of the escalations. Here's escalation 2. There should be a lot more than that though, because I think we have 1 through 8. Yes, I'm not sure why we're not seeing all of them. Unless they're not all on the same certificate authority. That could be. Let's see. Okay, if you don't have ESC4 set up on the lab, please update and run the following commands. Okay. And next year on, okay, now you should be okay with ACL and ADCS ESC4 settings. Oh wow, so we could actually do a path from cal.drogo to ESC4 and see that he actually has generic all over the ESC4 template. But we're just gonna, oh wait, so we have escalation 1, escalation 2 and 3, 4, 6, 8, and then we also have the CVE and shadow credentials. What is this exploitation for all of them? I don't think so. Oh, okay, this is just a, like a section for this. Okay. So, we did enumerate, and found out that, ESC1, the ESC1 template is vulnerable to escalation 1, Active Directory certificate services, abuse. So query the certificate, target the CA server template, the vulnerable template, UPN the target user we want to impersonate. Okay. Authentication with the PFX we request before. Wait, what? When did we do that? Okay. Oh wait, did we start with ESC8? Maybe we should actually start with ESC8. I wonder if there's a reason for that. Let's see. On this part, we will try attacks when a ADCS is set up in the domain. Active Directory Certificate Services is set up in the domain. First, we will use Petit Potom unauthenticated and ESC8 attack to get domain admin on sos.local. Next, we will enumerate template certificates with Certify, Bloodhound, and a user account. To finish, we will exploit the following attacks. Okay, so yeah, I guess we can do this in this order then. If it makes things easier. Okay, so I guess starting with escalation 8. This is actually completely unauthenticated, it seems. Which is really probably why we're starting with this attack, because we can actually do this as an unauthenticated attacker, which is pretty scary. Okay, so we're going to coerce to domain admin. I think I need Petit Potom. I'm not sure I have that. Okay, so to make this attack work, we will need ADCS running on the domain with web enrollment enabled. And we know that that is true, or we wouldn't be able to perform this attack. A working course method. Here we use Petit Bottom unauthenticated, but an authenticated printer bug or other course methods will work the same. There is a useful template to exploit ESC8. By default on an Active Directory, its name is domain controller. Yep, okay, that makes sense. Let's check if the web enrollment is up and running at... we can also curl this, I believe. If we didn't want to actually try to do this through the web browser. So yeah, I think we can just curl this. Let's just do that. I'll just copy this. And I'm gonna be working in the post-compromise tab now. I don't think we need to really do anything fancy. I don't think we need to actually even specify any flags, maybe. Let's see what this does. Oh, well, I'm gonna have to change the IP address because my lab doesn't actually uses a different subnet. 72.16.0. Oh shit. I think this would be 23. Right? Yeah. .23, which is Bravos. Okay, so let's see if we can curl that. I mean, yeah, this basically tells us that there is a web endpoint. Yeah, so basically we're just trying to determine if this actually exists, which it does. It is trying to prompt for credentials on that. So yeah, we've basically proven that this has a web enrollment. What does it say specifically? Yeah. Active Directory certificate services running on the domain with web enrollment enabled. Yes, so that's what we're proving here, or with curl as we did. So the server asks for an authentication, so all is fine. Smiley face. Add a listener to relay SMB authentication HTTP with impact at NTLM relay X. Okay. And then I need to grab Petit Bottom if I don't have it, which I don't think I do. Petit Bottom.py. Oh, wait. No, I do have that. Oh, okay. That's actually part of netexec. So... that means there must be a way to actually use it with netexec, but I'm not really familiar with how to do that. I'm not sure like what service we need to use or anything like that. Maybe we can look that up. Because it would be interesting to learn how to use it with netexec, because I didn't even know that you could. Well... maybe I did, but I've never done it myself. Okay, let's see, netexec Petit Bottom. How do we do that? Maybe this cheat sheet will tell us. Let me see if I can search for Petit Bottom. Ah, okay, here we go, sweet. Okay, so we can run this with netexec SMB, $DC, so we'd have to set a variable for that, or set that as a variable. And then we're just doing blank authentication. Okay, then dash capital M for module, and then Petit Bottom. Okay, so that's easy enough. That's not too bad. So let's just copy this. And then we're just gonna change this to an IP address. Okay. Let's see. So going back here. Oh, interesting. Oh, okay. So this should actually be the IP address for our attacker machine, I believe. Can you actually set this as the gateway? That's interesting. Okay, and then murine.sos.local is the domain controller for the sos.local domain. Okay. Alrighty. So, I don't even need to actually get petitbottom.py because it's built right into netexec. Okay, so all we need to do is we can just copy this and then just change a couple of things in here. So we'll just put this in. So this is, we have an NTLM Relay X tab that we were using before. We'll just use that. And then all we really need to do is change this IP, or part of this IP anyway, because the .23 is right. .16.0.23. Okay, so that's all right. Okay, so looking at the end, my freaking VM froze again randomly. Not sure exactly why that's doing that, but that has been happening recently. So we'll wait for that to normalize, which it usually does. Okay, so let's look at these options that we're setting here. So we're using NTLM relay x.py. -T is for target, so our target is going to be our certificate authority, which is at .23. And we're looking at we're specifying the web enrollment path specifically. And then we're going to use SMB2 support, and then --ADCS is specifying Active Directory certificate services. And then the template that we're going to be trying to abuse is the domain controller template. So I believe we just run this first. And then, let's see, the server, okay, add a listener to relay SMB authentication, HTTP with Impacket relay, Impacket NTLM relay X. Okay, and then we'll coerce. Yeah, so we're just gonna go ahead and run this first. Or not. Unrecognized arguments. The argument for this tool probably changed, and that's why this isn't working. I also kind of want to use, I like to use Impacket-NTLM relay X, like that. Okay, I still am guessing, though, that the --ADCS doesn't exist. Unless it does. Maybe it only exists for Impacket-NTLM relay X and not NTLM relay X.py. Or maybe we're gonna get an error. Nope. Okay, so that actually does exist if we're using Impacket-NTLM relay X instead of the Python script for that. Okay, so our servers are starting and we're waiting for connections. So let me open up a new tab, and I'm just gonna call this Petite Bottom, and I'm gonna put this next to NTLM relay X. I'm gonna make this bigger so you can see. Okay, so then we're just gonna use netexec, and we're gonna set the IP of Murine, which is .12. Yes. Okay, so we're gonna set 172.16.0.12. 72.16.0.12. And then -U, -P, and then -M, Petite Bottom. Alright. So we'll run that. Did that do anything? Oh wait, yeah, that should have done something on NTLM relay X. No, maybe not. Does this literally just tell us that this is vulnerable? Oh, next step. Okay. Is that opening? No. Yeah, so if we use the Python script, we should see attack worked, and then... Oh yeah, so we are supposed to get a base 64 certificate for the Murine computer account. So why are we not seeing that? Oh wait, did this open a new window? Okay. Oh, that's Bloodhound. I wonder why that link isn't opening. Let me just copy the link address. Paste and go. So what am I missing here? Maybe this is just delayed? No, we're not seeing anything here. Okay, so this is right. 172.16.0.23. Domain controller. I think that should be right. I think let's just make sure that we do indeed have a template called domain controller. I don't see a template called domain controller. Unless that doesn't, when we run certify, it doesn't show that default template. Unless it's part of this. So here's ESC6 and ESC8. Then we go into the templates. So we have ESC4. Oh, here's ESC3-CRA. Okay. Here's ESC2. Oh, wait. So, okay, so this one is ESC3 here. And then we have ESC2. The vulnerabilities are at the bottom. So here's ESC2 and ESC3. Then we have ESC1. Okay. There is a useful template to exploit ESC8. By default on Active Directory, its name is domain controller. So that should exist. I wonder if we scroll down here, if we see that here. Okay, yeah, so that should exist. We don't really have a way of verifying that at the moment, but... Hmm. Oh, this is with Certify, and this is with Petite Potom. Okay. Launch the coerce with Petite Potom unauthenticated. Oh wait, this will no more work on an up-to-date Active Directory, but other coerce methods authenticated will work the same. I wonder if that could be why. That does say vulnerable though. And I think I ran this correctly. Netexec, SMB, and then the domain controller, TechU, and then null argument, TechP, null argument, tech capital M for module, and then Petite Potom. Is there like an example of what this looks like? No, not really. Okay. Alright, well let's move on to doing this with Certify. I wonder if this just isn't working because we're on an up-to-date Active Directory environment and we can't do an unauthenticated coerce using Petite Potom. Okay, so let's move on to Certify. And maybe within by the end of the next 30 minutes I can get this get this done, hopefully. Oh, there is an ad running, so I guess we'll wait for that. "30 seconds. Do 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 do. Okay, I believe we're back now. Okay, so I'm gonna try to get this done in the about next 30 minutes. Running through using Certify to abuse Escalation 8 for Active Directory certificate services. Oliver Lyack has done a wonderful job on the ADCS attack tool Certify to automate a lot of things. Yes, Certify is amazing. Okay, so let's do the same attack with Certify. Set up the listener. Okay, so let me just copy this. And I'll just go to the post-compromise tab. And then we just need to change this, a couple of things in here. So I need to make this -AD, and then I have to change this, most of this IP, because that's not the subnet that I used for my lab. I used 172.16.0.0/24. .23 is Murine, which is the, not Murine, Bravos, which is where the certificate authority is. So let's see, do we run this? Yeah, so this is going to be setting up a listener. Following arguments are required. target. Okay. I think this is actually supposed to be... what was it? SOS-CA? SOS-CA and then dash target 72.16.0.23. I think that's right. Yeah. No. Okay. Oh, address already in use. Oh, is MenTLM Relay X still going? Yes. Okay, so I have to kill MenTLM Relay X first. And then we run this again. And it should work. Okay, so we're listening on port 445, which is usually SMB runs on that port. And we can see, just because of how this is set up, that this is escalation 8. Next thing, trig the course just like we did before with Petite Bottom. Okay, so we will use Petite Bottom to trigger this. We have to do this authenticated though, don't we? Oh wait, no. We're doing this unauthenticated still. Okay, so we'll see if this works. Okay. Let's see if this works. We'll run that. Did we get anything back here? No. Okay. We might need to use actual Petite Bottom. I would think that this would work with netexec, but maybe it's not. It's a specific situation or something. Yeah, let me download Petite Bottom then. I think did I have that open somewhere? Yeah. Here we go. So I just need the Python script. Just download that. And I'll put that on here. Okay. Go back here. Copy this. Change a couple of things. So now this should be here. Python 3 tbottom.py. Let me just do this. .172.16. Oh, wait a second. No, that's not. That wasn't the issue. Let's see. So I think I need to know, unless, I guess, maybe I can just use the gateway to do this. I thought that it had to be the attacker IP though. I mean, I guess we can try it with the gateway first. Okay, and this is right, mirroring.sos.local. That's the domain controller for the sos.local domain. Okay, so let's see. So we've got this listening. So let's try this. Something went wrong. Error connection. Name or service not known. Yeah, let's see. Geez, I have a lot of adapters. I'm not really sure what that is. Okay, why do I have 2 IPs? Okay, so East 0. Okay, so we're at det 29. Okay, so let's try this. Wait, we're still getting an error. Wait, marine.sos.local doesn't have 445 open? P 16.0.12. No, it does. What is the issue then? And let's see, NS lookup, marine. Can't find marine? Okay, let's try the IP address then. 172.16.0.12. Let's try that. Okay, so that seems to be working. Okay, so we have a certificate and private key that were saved in marine.pfx. So the attack did work. Okay, awesome. I still don't know why this didn't work with netexec. But anyway. Okay. So now we have a .pfx file. Next thing we need to do. Now we have the certificate, so we can get the NT hash of the DC and also the ticket granting ticket with the command. Okay, so let's copy that. We'll change a couple of things with that. I do need to change this to certify-AD. That is correct. Then I just need to change this IP address. 172.16.0.12. Okay, so we'll run that. This should give us the NT hash for the Marine $ computer account. Okay, so we have that. So now if I think we just need to grab the LM portion. And what are we gonna do next? Oh wait, so we did get a ticket granting ticket too, right? Yes. And that was saved to marine.ccache. So we don't actually need to mess with the NT hash. Or the LM portion of the NT hash. Okay, so we need to export this to in a variable of KRB5CC name. Okay, then we're gonna run secrets dump. Okay, so export KRB5CC name equals home x hobgoblin documents code marine.ccache. I don't think this needs to be in quotes. No. Okay. So that should work. And then we'll just do echo $KRB5CC name to make sure that's set right. And it looks like it did. Okay, so then we'll run secrets dump, specifying Kerberos for authentication. We're specifying no password. And I think all of this should work. I don't think I really need to change anything here. Okay, so I do impacket -secrets dump and then -k for Kerberos authentication using the Ccache file. And we're not going to specify a password, so that's why we're setting no pass. And then we're going to be authenticating to the sos.local domain using the marine $ machine account at marine.sos.local. So let's give that a shot and see if we can dump all of the hashes for the sos.local domain. Policy SBN target name validation might be restricting full DRS UAPI dump. Try just DC user. Okay, I'll try that. just dash DC user. Expected one argument. Oh wait, do I need let's see. What if I do just DC instead of just DC user? No? Okay. Maybe I need to set the DC IP. DC IP 72.16 at 0.12. Let's try that. No? Plus the SPN target name validation might be restricting. Okay. Administrator? No. Mirroring $sign? No. What do you not like here? Let's use the IP here instead of the fully qualified domain name. 172.16 at 0.12. Let's try that. No? You don't like that either, huh? DC-IP 16.0.12. No. 10. Well, damn it. Not sure what the issue is here. Wonder. I think this is right. This needs to be a /. I think DNS should be working though, so I'm not sure what the issue with that is. Maybe this will work? No? Well, crap. I wonder if I have anything about this in my notes. Because I know I've run into this issue before and I've overcome it. I just don't remember how exactly that worked. Let's see. Oh, whoops. This still definitely has to be in quotes. No? If I just do this. No? Okay. Why does that work? I feel like this is a DNS issue. So what if I ping mirroring? I'll just do 4. Okay, so that's working. If I do mirroring .sos.local. Name or service not known. Okay. Yeah, I think this might be... Well, it shouldn't be a DNS issue, I wouldn't think. Well, yeah, it still could be because we probably need this full identity. The domain and the user. Okay. Do we have to do... I wonder if we have to do this way. Probably. Maybe not, though. Let's see. So what I wanna do... You know, let's see, hosts. I wonder if this needs to be like this. Okay, so if I ping this now, that should work. Okay, so let's try this again the very first way, which was somewhere. Yeah, let's try this right here. See if this works. Oops. No? Wonder how I got this working. I also ran this previously as rob.stark to dump all of the hashes from the north.7kingdoms.local domain. I want to see what the syntax was for that command. Let's see. Come on. Would you get there already? Come on, let's go. Oh yeah, here we go. Okay. So in packet-secrets dump, and then we have the full identity here. So we have fully qualified domain name, and then rob.stark for the user. I mean, obviously there's a password in here, but that shouldn't matter. And then we have @ and then the IP address, and then -dc. Okay, so let's give that a shot. This is the wrong tab. We're working out of the post-compromise tab. Okay, so really, I think all we need to do is change this to 172.16.12, and then do -dc. Will that work? And that still doesn't work for some reason. Wait a second, is that? I think that's right? Wait a second, I think... No? I did that right. Now we got the certificate, so we can get the NTH to the DC and also the TGT with the command. So yeah, we have the Ccache file. So that's right. And then we should... Oh wait, we can... Oh, let's try this with the hash instead. And I'll just replace this portion. Let's try this with the hash instead of the ticket, the Ccache file, which is the ticket granting ticket. Okay, So instead of specifying all that crap, we're just gonna do this, and then put that in there. From up here, wherever that was. Okay, yeah, so we have the lm portion of the hash right here. Let's try the hash instead. Maybe we'll have better luck with that. If not, then I'm probably gonna wrap it up here. The following arguments are required. Target. Okay. Dash target dash IP. But we're already specifying that we're trying to authenticate against .12. What? So what do you mean? I don't think that's specified here, is it? No. Oh, oh, wait. Okay, so I still have to specify dash no dash pass. So I want to add that back in. Dash no. I don't think it matters where I add that, really. Let's try that. No? The following arguments are required. Target. What do you mean? Is this not target enough for you? What are you on about? Does this like need to be escaped or something? I don't think so. What is the damn issue? Mirroring.sos.local. Try that. I don't think that should make a difference, though. Maybe it will, though. We'll see. No. The following arguments are required. Target. What are you talking about? What does that mean? Sometimes I really hate the syntax for InPacket. Hey, welcome in, Bugsick Bunny. Split the hash value? What do you mean by that? Is it because I have that there? Do I need... I wonder if I need the full hash. I wonder if I need the NT and LM portion of the hash. Where is that? Oh, here it is. Let's try that. Maybe that's the issue. Oh, wait a second. Could it be... I wonder if it's that this is not supposed to... Okay, so what if I get rid of this? No? Okay, let me add in the rest of the hash. Okay, so whoops. I need to get rid of one of these colons. I guess I'll put sos.local back. Will that work? No? I mean, push space value before sos.local. Put a space value before sos.local. Oh. Is it because I don't have a space? I didn't realize I didn't have a space there. Gosh dang it. Okay, let me try using the IP address then again this time. 172.16.0.12. Maybe this will work this time. There we go. Okay. There we go, finally. Okay, so then what's the next thing we need to do? Okay. So we got all those hashes. ADCS, reconnaissance, and enumeration with Certify and Bloodhound. Is this still part of... Oh wait, no, so that was the end of... Hey, and that was right at the end of the time. That's awesome. Okay. So yeah, I think I'm gonna stop here for today. Oh, there's an ad going on. Gosh dang it. Are there any other InfoSec streamers on? No, it's just me? Okay. Well, after this ad ends, I think I'm gonna end the stream. Five, 4, 3, 2, 1. Okay, we're back. What is that project? Oh, do you mean... Are you talking about this? This is a game of Active Directory from Orange Cyber Defense. It's a fully vulnerable Active Directory lab. Yeah, so I'm going through that, and there's a lot of vulnerabilities and misconfigurations in this lab, so there's a lot to cover. I kind of started out doing it as a pen test, but I've pretty much compromised everything except for the root domain controller. I'm kind of stuck on actually compromising the root domain controller from where I'm at now. So now I'm just looking at kind of a cool topic, which is Active Directory certificate services abuses. So we just did escalation 8. And we're able to escalate as the to the domain controller. So we impersonated the domain controller and then dumped the ntds.dit secrets, which contain all of the password hashes in the domain. So for the sos.local domain, we've dumped all of the the NTLM hashes for every single user in the domain. Why is there another ad happening? There is a big lag on the stream for some reason. Not sure why that is. Is it okay now? Seems to be somewhat alright now, maybe? Alright, well, anyway, I think I'm gonna go ahead and end the stream there tonight. Thanks everybody for joining. I plan on streaming again, at 7 Central, US on, Tuesday, so hopefully I'll see you then. But anyway, hope everybody has a, good rest of their day, night, afternoon, whatever it is for you. And I'll hopefully see you next time. Thanks. Bye. Do, 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 do.